Welcome back to another HVAC-Engineering-Techie training video. Today's training video is on retrocommissioning systems testing. So this is number Cx-25 in our series of training for retrocommissioning. So I think this will be beneficial to you on exactly how you test the systems to discover issues, is what we're looking at today. Remember, this is a channel that talks all things HVAC from engineering design, construction equipment, systems, tab, controls, and energy and performance of HVAC systems. I'd like to ask you a big favor. If you've not already become a subscribing member, boy, I'd really appreciate it if you did. All you do is hit that subscribe button down below and give me a thumbs up if you like the video. It's totally free, costs you nothing. And that's done because Google uses that to evaluate the video, and that keeps me on the air. So I'd really appreciate it if you would do that. It could be really helpful to me. So let's get started on talking about system testing. Thanks. All right, so now we're just going to review the videos. If you've seen some of these, you've been through this before, but just in case you're new, I'll make sure you understand these are the videos we have for retrocommissioning. Cx-20 is the technical retrocommissioning process. 21 is the retrocommissioning overview of the matrix, which is similar, but it's a different format. Cx-22 is the RCX contracts and pre-project planning. 23 is pre-site activities. 24 is system assessment and issue discovery, an important one. 25, which is this one, is RCX testing, systems testing. So how do we exactly test the systems? That's what we're going to talk about today. 26 is the root cause identification and issue analysis. This is a key one. It's not real long, but it does tell you exactly how to figure it out if it's a root cause or not. 27 is quick fixes and systems optimization, an important part of our process. 28 is corrective actions and post-project activities, how these things end up. So let's kind of talk a little bit in general here for a minute. What creates a low-quality retrocommissioning project? And there's been a lot of them out there, I can tell you. So these are the things you do that will end up not giving much value to the customer. Trust only your ability to sleuth out operational issues. You know, a lot of guys are good at what they do, so they walk onto a site and they walk around and, oh, that's wrong and that's wrong. And that's all they do. They don't do any testing. They don't actually dig down deep to find root causes, and that'll give you a very poor project. You'll find problems, but you won't find good solutions. Using a single focus approach, such as energy, comfort, or operations, you need to be holistic in nature. You need to look at everything. Once an issue is discovered, immediately jump to the assumed correction. This is a pit you can fall into if you're not careful. Oh, yeah, I see that. Well, I know exactly how to correct that. Don't do that. Just write it down as an issue and look at it later, because most of the time there's more than one problem affecting an issue. So you need to be careful with that, because if you don't do that, you'll end up treating symptoms. Look only to low-hanging fruit. Only look at what you can see. Perform no system testing because it's expensive. Spend no time verifying the root cause of each issue. You know the issue. You've seen it. No, you need to make sure you have the root cause. Trust others to make corrections. Don't make them yourself. Don't check them. Don't commission the corrections. That's a path to failure. Offer no training to operators for corrected system operation. Just assume it's going to get better and they'll just keep it better. If they don't know what they're doing with it, it won't get better. It'll get worse. Do not take responsibility for results of your project. And that's what a lot of people do. They say, well, I showed you. It's not my problem. It didn't work. Well, it is. If you're doing a retrocommissioning project, you need to make sure what's corrected actually does what you said it's going to do. So what's a pathway to a high-quality project? It's opposite of those things, obvious, but use a holistic approach, making no assumptions for corrections. As you perform the discovery process as outlined in video Cx-24, and of course in the ANSI standard. Gather discovery data from all possible sources. Don't make judgments on just one piece of data you got. Make sure you look into everything around that issue to make sure you really know what its cause is. All initial systems must be tested to verify they are working properly by one or more of the following tests. Now, this is right out of the standard. We had a hard time figuring out how to do this, because one of the methods many of us had always done is just test everything. Well, many people complain that that's too expensive. We don't need to test systems that are working fine, and they're right, you don't. So what we did was we put in there that you're going to test everything enough to know if it's working or not. If it's working correctly, you don't need to continue. But if it's got a problem, then you need to fully test that particular system. Initial system must be tested occupants by one of these following ways. Occupants and operator interviews. As you walk around and talk to people, they know if they're happy or not. Space data loggers is the easiest way to tell what the space is doing. And that's actually best practice to do both of them, not just one of them, but those two, at a minimum, those are the two you should do. You can do tab testing, as found testing. You can do control testing, point-to-point testing. And to be quite frank, you're going to end up doing those before this is all over anyway. So a lot of times it's just better to get it out of the way. Just go ahead and do an as found survey while you're there. Go ahead and do a point-to-point test while you're there. Get it out of the way. And then you'll know it won't be covering anything. And if it's a system that is working fine, that's all right. You needed to do it anyway, so it's good. So system discovered to have an issue or selected for additional testing. Verify that every issue is linked to a root cause. Train operators for corrected system operation. Take responsibility for the results. This is the best marketing you will ever do, is follow up with the customer and ask him how it went. And if you did a good job, he'll be ecstatic. And that's when you need to get his endorsement. And it'll be like gold, because other owners will believe other owners before they'll believe you. So that's really good marketing to do. All right, system of testing. So all systems are testified they are working properly by one or more of the following tests. We've already talked about this. Occupant and operator interviews, space data logger trends, or control point testing. And that these three are best practice. So you're probably going to end up doing these anyway. Because what we find, there's problems always with point testing. There's always space problems and the occupant interviews you need. So these are your observation. And then tab testing. A lot of us do tab testing at the same time, which is as found testing, not a full balance. You just run through and record the CFMs you're getting and the flows, water flows you're getting at that point in time to tell, are we anywhere near range or are we in pretty good shape? And it'll help you in your discovery process. System and equipment assessments. We did a whole bunch of assessments. Systems are separated into two groups, system with issues and system without issues. If the system or zone is proven to work correctly, no further testing is required on the system or zone. However, optimization will be done. Optimization and corrections may be performed of both systems if corrections are found to be beneficial. Control sensor calibration, control program revisions, and test and balance. And these are best practice to do it on every system that you have a co-owner. It's just easier to get them out of the way, to get them done. Go do a control sensor by part of a point-to-point test and do a test and balance as found. And as you're going through an as found and you find a diffuser that someone's blocked off, you remove the blockage and put it back to design CFM. That's a quick fix, but you might as well just get it done instead of waiting to do it later. A system with issues. How to select what are tested. Follow the type of issue or complaint. Perform high-level overall system testing. And verification. Check systems and verify basis of the complaint. They said it's not comfortable. It's too hot. Well, go to the space and test it for yourself. Is it too hot? If it's not, now you got another problem. You got to decide whether that's just a person that's complaining or if it's sometimes it's hot, sometimes it's cold. And you do that through your data trend. If your data trend showed it was in temperature all the time and in humidity all the time, then it should be comfortable. Then that's a different situation. Check basic mechanical, electrical, and control operations. Is the system operating correctly? Use quick fixes to correct any obvious issues that may cover up other less obvious issues. Deferred maintenance. You can't test a system and correct a system if it has deferred maintenance issues. Verify that no other system is directly affecting the system in question. One system may be having a problem because another system is fighting with it and it's affecting that system, so you want to check that. Perform as found system testing for tab and control testing. So on systems that need to be tested, this is one thing that needs to be done. Create a testing plan based upon the initial findings. Normally on these two, it's just easy to go do that as found and get it out of the way. Remember, the process may not be linear, but you may have to circle back when testing indicates a different or another issue. So you're looking at one issue, and you're working through your test notes, so you say, well, man, that's not right. Doesn't have anything to do with what I'm doing, but that ain't right. So now you have another issue. So you may have to go back and look at some previous data to tell what's going on with that system. Add to RX issue log as issues are discovered. So when you discover an issue, put it on the log. Perform as found tab survey tests for all systems that have been found to not be working correctly. Use as a part of the discovery process. Minimum readings shall be as follows. Record as found flows for grills and registers. Record as found air total flows per terminal units. Record as found air flows and pressure profiles of air handler units. Record outside air flows and building pressure. So this process right here, you're going to need this for the terminal units because you got to calibrate the terminal units anyway. I guarantee you, unless the system has just been balanced, the boxes will be out of calibration. It's almost a guaranteed thing. It's something you have to check because not all of our jobs are actually done correctly. And if something's going to be done wrong, box calibration is number one suspect. So you need to check those anyway. And building pressure is another one. Record entering and leaving air temperatures of air handling units. Record primary water flows, temperature, and pressures on pumps, chillers, boilers, and heat exchangers. Verify terminal units are correctly calibrated, and you've got the data up here to do it. Create issue log items for any major issue too large to be corrected by quick fix. So if you got something in front of you that you can't do by quick fix, then you need to put it a special issue log item, and that may be something you may have to talk with the owner about trying to get corrected soon. If it's something that's affecting the remainder of your work, if it's going to cover up something, we need to get that one corrected. For instance, say there's a piece of duct missing, not just not connected, it's missing. And that diffuser, that air in that room has absolutely no air because there is no duct. But that's more than a quick fix. You don't have the duct. So that needs to be fixed prior to moving on. So it's not like a capital improvement. It's a fix, but it's not a quick fix. Testing of systems with issue. Perform as found control system point-to-point tests for all systems that have been found not to be working correctly. Use as a part of the discovery process. So minimum point test should be test calibrations of all controlling sensors. Now you don't need to calibrate a status sensor. If it's a display air sensor, it's not controlling anything, it's just there to tell you if the system's working or not. It could be a degree or two off, no one would care. So you don't really need to calibrate. You can if you want, but you don't need to do that. You need to test range all actuators. And remember, when you range an actuator, you want to make sure it goes full closed. You don't really care if it goes 100% open, but you really want to make sure it goes full closed. Test all point functions from the graphic to the end of base. You want to make sure the graphics are correct. Include start, stop, status, polarity, and modulation to set point. That's what you're looking for when you look at those things. Test integration points for proper operation. So if you have a system that's integrated with another system, then you need to check both systems to make sure they're talking properly. Test basic control loop functionality. Test reset sequences of control for proper operation. This is actually kind of important. It's resetting, is it correctly? When you're doing retrocommissioning, you will normally find the majority of reset sequences are incorrect, not working, or blown out entirely. And unfortunately, reset sequences are what makes your building energy efficient. So if you're trying to improve energy at all, you've got to do these. Inspect graphics for required operation data points. Do they have enough points to actually operate the system? And the reason I'm saying that is because a lot of engineers don't actually know what points are needed, or don't even say. They just say it's going to be on a graphic. The control guys will put the points they normally do. They don't really know if they need that point. And operators don't normally have a voice. No one asks. Well, you should have enough information to say that I need that point. I couldn't operate this system without that point. So I need to show that point. Create issue log items for any major issue too large to be corrected by quick fix. Test for specific complaints. Okay, let's see what we do for a specific complaint. So let's say the complaint was the temperature is too high or too low in a space. Check the room sensor calibration. Is it correct? Check the room humidity level. Check the scheduled start time. Test flow to the airspace. Test temperature of the air to space. So is the incoming air too cold, too hot? is that why we're not cooling or heating? Observe if any changes in the heat load has been added. If they added or subtracted a great deal of heat load, verify the VAV box calibration. Check chill water temperatures in the air handler or DX unit discharge air temperature. Do we have the right amount of energy coming out and leaving the space? Controls operation and functional testing. Verify the temperature set points resets are working correctly. All right, so what if the complaint is high humidity level? Most people don't complain about low humidity unless it's a clean space, but let's say it's high humidity. You check the humidity room sensor calibration. If it has a humidity sensor, you got to check its calibration. Check the scheduled start time. Verify the runtime of the air handler package units. When it comes to humidity, package units are the very worst. And what happens a lot of time is they don't have enough. They have way too much capacity, so their runtime is short, and they don't dehumidify the air enough to drop down the humidity level. So in those cases, you have to lower the airflow on the package unit. You can only go so far, though. You lower it to get as long as runtime as possible, and to make sure the air is colder across the coil. And less airflow will do that. Now, you can't reduce a package unit down below 25% or so of design airflow because you can damage a compressor. Test temperatures of the airspace, because temperature and humidity act together. Verify the airflow of the space. Observe if any changes in heat or humidity load have been added. Verify VAV box calibration. Again, check the chill water temperature in air at the air handling unit or the DX unit discharge temperature. Controls operational and functional testing. Verify dehumidification, chill water reset sequences. If you have a dehumidification sequence, and if you don't, maybe you should add one. Testing for specific complaints, airflow and ventilation. One of the complaints is, man, it's stuffy in here. Well, stuffy can mean we don't have enough fresh air, or it can mean we don't have enough ventilation air, because people are more comfortable if they have air velocity across them. If there's no air velocity, then it will seem stuffy. So that's what we're looking at for airflow or stagnation. Test flow of the air to the space. Verify air velocity to all areas of the space that we have some velocity. Test temperature of the airspace. Test the humidity level of the airspace, because both temperature and humidity can affect how a person feels about airflow and stagnation. Test outside air ventilation flow and outside air volume getting into the space. Observe if any change in heat load have been added. Verify VAV box calibration. Check chill water temperature and air handler at the DX unit discharge temperature. Now you can see for a lot of issues these are all the same tests, but these are the correct tests. Control operational functional testing, and again to make sure you have airflow. All right, what about air quality? Now this is a more serious one, but air quality is normally a person says, I feel, not only is it stuffy, but I feel it in my throat. I don't feel well. I feel dirty, dusty. I feel I smell dust all the time. My body's reacting to whatever's in the airflow here, and those are serious issues. And sometimes they're very hard to find and trace. But verify air filter maintenance and effectiveness. How is there any deferred maintenance as far as filters? Is the coil clean? Is the coil pan clean? Is there no green growies anywhere on any of this stuff? Because if you have a very dirty coil, then the dust alone could cause a problem. Or if you have growth on the coil or the pan, that growth produces spores, and the spores can go in the air, could affect a person, especially if a person's allergenic to those kind of things. Verify air handler and air coil drain or pan are clean. Verify that no chemicals are stored in the air handler plenum area. You're not supposed to store anything in air handler area, but unfortunately people don't know. So a lot of times the janitor crews will store their stuff in an air handler room. They said, look, man, it's got lots of space. They don't realize it's part of the return air plenum. A lot of return airs, the rooms themselves are part of the return plenum. And you put chemicals in there, guess what? You're just pumping chemicals through the whole building. So they shouldn't be storing anything in an air handler room. Even if it has ducted return, they shouldn't be storing it. Observe if any contaminants are present in the space. Where is this contaminant coming from? Is it coming from through the air handler system, or is it coming from the space? And a lot of times you'll find things that are growing in the space that should not be, like black mold. Black mold, I've seen it underneath the tile on the floor, coming up through the floor. I've seen it pinpoint hole poking through a wall when the other inside of the sheetrock is covered with mold. Or you could see Legionella if there's water anywhere inside the space. It could be Legionella on the showers or on the faucet fixtures. So that you can look into that kind of stuff. Test flow of air in the space, verify air velocity of all areas in the space. This is also important that we have air movement and that we're exchanging enough air to clean the air. Test the total building for building pressure. It could be this part of the building is very leaky and the outside wind is forcing things from the outside into the space. So that's not good. Test temperature of the air in the space, test humidity levels, test the outside ventilation flow and outside valve volume getting into the space. Verify the VAV box calibration. All of those things still can affect contaminants into space. So for noise or vibration, I don't know if you guys have done much for sound testing, but that is also a complaint because we're dealing with comfort. How comfortable are people in a building? Measure sound and vibration levels in the space. Trace sound of noise or vibration intrusion. Now, when you do that, sounds are caused normally by rotating or vibrating equipment. So if you can test the frequency of the vibration, you might get a hint at where it's coming from. I've had systems where we had noise and vibration in space, and it was actually coming from a pump 3 stories down in a central plant. And it didn't show up anywhere else except this office on the 3rd floor. Go figure, you can't tell how it's moving through a structure. But it turned out the pump had a little problem, it was kind of out of balance. So we balanced and put it on spring isolation, the thing went away. So you can't do that way. Verify sound absorbing properties of the space, walls, floors, and furniture. I've seen buildings that are beautiful buildings, but the architect is taking all the soft surfaces out. Hard tile floors, plastered walls, hard ceilings, and glass, no soft surfaces, and they complain about noise. And I tell you, you can't do anything with it because the noise reverberates throughout the system. Test airflows to space and condition or portion of grill defecting veins. You want to make sure that the air is moving in the right place. Verify if any recent HVAC changes have happened. So did this get worse when they made a change? Sometimes you can find out they do things wrong or incorrectly, or put a different size piece of equipment in, which aggravates these issues. Investigate sound dampening materials and vibration isolation. Here's lighting quality. Could be another one. Believe it or not, most of the complaints anymore is being too bright, not having enough light, but being too bright. Measure the light levels at desk height. Test lighting controls. Verify light level change control settings. Verify light source temperature levels from the light fixtures are all between 2300 and 5000 K. 5000 is actually too bright. I like to be right around 3000, 3200, right around in there for light levels. A nice warm light. It's not terribly warm, but it's not. 5000 is stark white, and it's very hard on the eyes. Verify if any recent space or lighting systems have aggravated the issue. Verify windows direct sun intrusion into space. It's one of the problems with indoor comfort is intrusion of the sun. It makes it uncomfortable, it shines on you, and it causes glare. So if we can get rid of that, it probably help. Observe reflective quality of glare of space, walls, floors, and furniture. If they have shiny surfaces that reflect sunlit and windows, then it's going to be a problem. Testing for specific complaints, excessive energy usage, system energy usage. Determine separate energy used by source, HVAC, light, and plug load. We've talked about that in the section of doing assessments. Determine correct operating schedule or utilize, that they have them on just the right time. Determine correct temperatures and humidity set points are utilized. Trying to dehumidify a building is very expensive, so you want to make sure they don't have it set down. Well, we want it 35%. It'll cost you a fortune, or vice versa. Let's say you're in the middle of the winter and they say, we want our building at 50% humidity. It takes a lot of water and a whole lot of energy, so that won't work either. Check if space set points to be used by occupants are limited. So you want to make sure that occupants don't have full range of temperature adjustment. Now, I know that might be a political issue, and some people may have to have that, but having a plus or minus 2 degrees, so you can be at a range of 4 degrees, that's certainly comfortable for people, and that doesn't drive your energy over the wall. Some people only have plus or minus 1, but plus or minus 2 is okay, but you don't want them having plus or minus 10, where they can now destroy your energy efficiency. Check to make sure windows cannot be operated by occupants. That sounds strange, but if the occupants want like the fresh air, so they open their windows and they leave them open when they leave, now all of a sudden your building is open to the ambient and you can't control it. Verify temperature resets are working correctly. Remember, temperature resets and humidity resets, all resets are key to energy efficiency. Verify economizers are working correctly. Verify no deferred maintenance issues remain in any facility system. Deferred maintenance are not an option. They cannot be there. Verify all light sources are off. The space is not occupied. Verify enclosure is airtight and correctly insulated. So those are all the things to do for energy. Now, what about water? A lot of attention to, but it's getting to be something expensive. Make sure the plumbing systems aren't leaking. Now, you guys may not know, but a plumbing fixture that's leaking just a little can use a horrendous amount of water. You know, a ball cock inside a toilet fixture that's leaking by a little bit can use 1,000 gallons a month easy, maybe 4,000 or 5,000 gallons a month. So just a leaky fixture can be very expensive. Verify incoming water pressure is set to the lowest operating pressure. Remember, that pressure is whatever's needed to get the flow valves on the top story to work. They need 15 to 20 psi, not more than that. If you have overpressure, the flow valves don't, they're a pressure-actuated valve, so they stay on way too long and they waste a lot of water. Verify all fixture flush valves are properly adjusted. Verify all irrigation zones are properly programmed and are operational. The two main water usages in the building is plumbing fixtures and irrigation. That's the two main water systems. Now, third is if you have a mechanically water-cooled system in your building, it will be the cooling towers. Cooling towers use a whole bunch of water. But those are the three operational things. Verify all irrigation emitters are flowing the correct amount of water and are not overflowing or watering non-existing plants. What happens is the architect designs a landscape and he says, this is the kind of plant I want to use here, and it needs 2 gallons of water a day, and here's the right emitter, on down the line. Well, 5 years later, that emitter stopped working, that plant died, they ripped it off, never bothered to plant anything, and didn't plug the emitter. So the emitter is still watering the empty hole. And that happens all the time. Or else they plant a different plant in there that doesn't need 2 gallons. It needs 1 gallon of water. So it's not as easy as it sounds, but I guarantee you that over time, they're not working correctly. Verify cooling tower cycles of concentration is greater than 3.5, and that water treatment control systems are working correctly. Like, again, this is one of the major uses of water. 100-ton cooling towers can use 1 million gallons a year. Think about that. It can use a little less, but if it's got a cycles of 1, which is per fresh water, your tower's not working correctly at all, because that'll scale like crazy, and it uses a ton of water. So your cycles of concentration should be up around 3.5. You get over that, you'll start scaling the system, but that's right the sweet spot you'd like to be. Verify boiler system water treatment is working correctly. Boilers will foam, and when they foam, we have a whole bunch of drawdown on boilers. So we want to make sure that defoaming agent is working correctly. Verify if hose spray is used for cleanings. We need if they're complaining about their water usage and they're using spray hoses to wash off sidewalks and patios, tell them to try using air or brooms. So that's it for system testing. I hope that cleared up some things for you a little bit, or at least helped a little bit. Anyway, appreciate you watching. Thank you very much. I'll see you on the next one. Have a great day. Thanks.